Hi, I'm Michael. Welcome to Starlight Xpress. Starlight Xpress is a UK-based company and has been designing cameras for amateur astronomers since 1989. The cameras nowadays are very different to what they were back in 1989. This is our latest cameras, the Trias Pro CCD cameras. The CCD in this one is actually a Sony ICX694, 6 megapixels, 4.5 microns, with a very sensitive 70% QE, 77% QE. The CCD chamber itself is purged with argon, so there's no chance of condensation within the CCD chamber itself. The camera acts as a heat sink to get rid of the heat from the cooling of the CCD. And as the body warms up, the front window is made of fused silica, so that warms up as well to stop dew forming on the front window. It's also AR coated to stop any reflections from the optical system. The front plate here is actually movable relative to the CCD, so if you have any collimation issues, you can actually remove that from the optical system. On the back itself, we have a built-in USB hub, so your guide camera, your filter wheel, and maybe your focuser can all be driven from the back of the camera. We have a 12-volt DC input. At full cooling, we only take about 1.5 amps, so you can run this off a car battery all night if you're doing remote imaging at all, or a star party. USB 2 cable connector for back to the computer, and we also have an auto guide port on here as well. All our small Trias Pro cameras are all in this lovely blue, cool blue anodizing, which is now the corporate colour for Starlight Xpress. Moving on, we have the guide cameras from that we've been producing for many years now. The original Lodestar itself was designed back in 2008 and was renowned then as being the best guide camera on the market. Since then, we have the Lodestar X2 and now the Lodestar Pro, which is the latest version. The Lodestar and the Lodestar Pro, etc., all have a half-inch format, 752 by 580 pixel CCD. The QE on this is 77% and the low read noise as well. We also have the Ultrastar and the Ultrastar Pro, which is this one here. The Pro series are now in the cool blue anodizing. The CCD on this one, the QE is about 75% and is about twice the active area of the original Lodestar. So if you're looking for a wider field of view for your guide camera, then this is obviously a very good option. Both cameras are driven and powered through the mini USB on the back here, and we have a standard auto guide port on the back. We find a lot of people now are using the Ultrastar Pro, especially for outreach programs. We have live stacking software free on our website, and with this, because there's no extra power supplies, just plug this into your computer. It creates a very good auto stacking live video type environment. Moving on, we have the filter wheels that we produce for Starlight Xpress. This is the Starlight Xpress MIDI filter wheel. So this is typically a 7-position 1.25 inch. We also do through 36mm mounted filters, 5-position 2-inch filters, and 5-position 2-inch unmounted. This is driven and powered through the USB, so you don't need extra power supplies. The MIDI, the Mini, and the Maxi filter wheel, which we have here, which is the very large filter wheel, they all have the built-in off-axis guider, which our Lodestar, obviously, and the Ultrastar can just screw directly onto. It has a C-mount thread on the front. We also have the standard filter wheel, which doesn't have the off-axis guider built in, and is a slightly thinner system. Most of the refractors that use focal reducers, they tend to have a sweet spot of about 55mm of back focus. We've designed this system with our cameras in mind, obviously, but these can be used with any camera. The back focus of our cameras is about 17mm, so the total back focus of this system is about 55mm, which is obviously hitting that sweet spot. All of our filter wheels have thumb screws on the front, so if you do need to change filter wheels, etc., you don't need specialist tools, which is great if you decide to go to a start party and forget that central tool. And they're fairly lightweight, and obviously make a great little package set up like this. We actually have package deals on our website and through our dealer system. Effectively you get a filter wheel, camera, and the guide camera as well, and they are several $100s cheaper by buying the package than buying individual parts. The next thing we have is the active optics system. This is our active optics. We say active rather than adaptive because we're not trying to adapt for the seeing conditions. We're trying to just create an active optical system to make fast corrections for your guiding. We have a piece of glass here, which is a crown glass, AR coated both sides, several layers of AR coating. And as the light passes through, we move the actual optical window, and the refractive index of the glass actually shifts the image around on the main camera, which will be sat behind the active optics. We normally have a peg-off prism assembly, like an off-axis guider, or you can obviously attach it to the front of any of our filter wheels and use the off-axis guider built into that system. The great advantage of these is that we can make very accurate and very quick corrections. The corrections are done in about 5 milliseconds. So the download time of the guide camera is really the limiting factor of how many updates per second you can do on the system. We have some customers typically using 10-15 frames per second as updates, but we do have some, if you have a very bright guide star and a good enough guide camera like our Lodestar, then you can get even higher frame rates than that. The idea of this is that we are negating the hysteresis in the motors of your mount, so we're not relying on your mount to do the tracking, so there's no lag in the correction. We're making the correction optically. This works really well from systems from around about 1 meter, 1.2 meters upwards, although you can see those corrections being made even on shorter focal length systems. But as I say, for an SCT, long focal length Newtonian, and even long focal length refractors, this is a really good option. Last but not least, we have our spectrograph, which is this system here. This is our original spectrograph. We have a built-in guide camera here. So you actually use the guide camera to position the object that you're looking to image, and we give you crosshairs in the software to align it to the slit. And then once you get the object on the crosshairs, then you know that you're actually on the slit. The resolution of this system is around about 2000 R. The camera fits on the back here. The actual spectrum itself is about 31 millimeters long, so it's quite wide. So if your CCD can't cover the whole spectrum, you can move the camera relative to the plane of the spectrum to look at specific parts of the spectrum that you're interested in. We also have a built-in reference lamp in here, and the whole thing is fairly light compared to the it's around about a couple of kilos, but the main thing is that it's solid and very robust as well, so you don't get any changes with relative to heat, relative to the ambient temperature. So that's our spectrograph. We also have a new version coming out very shortly. That is a fully automated system, so your focusing of the camera, your positioning of the camera on the spectrum, the slit position, the auto guider, the reference lamp, and we also have a flat field lamp built in as well. That is all controlled via USB, so this makes it a system that you can use remotely rather than having to be there to change the slit or move the camera, etc. So this makes it a lot more versatile. Well, thank you very much for listening to our presentation. We have a number of products on our website and various adapters and obviously a lot of different cameras. Please do take a look. The site is sxccd.com. So thank you very much for listening to the presentation. I hope you have a wonderful weekend. Please stay safe and fingers crossed for some clear skies. Thank you very much. Bye-bye.